Welcome students to the second video of this playlist. In this playlist, we are discussing about statistics. We're trying to understand each and every building block of statistics. In the last or the first session, the first video of this series of videos, we discussed what is a roadmap for statistics. We understood there are two sections. One is descriptive statistics, another is inferential statistics. Now today, as we promised in the last session, that we'll discuss about moments. Why moments? Because in the descriptive statistics, if you remember our discussion, in the descriptive statistics, we have to first understand moments, right? So therefore, the lecture 2, which is today's video, says moments. Okay. Now, what is moments? So before deep diving into moments, if I ask you to describe a person, how would you describe a person? You would describe the person by saying, this is the height of the person, this is the weight of the person. You would say that this is the color of the person. You may talk about the asymmetricity or symmetricity of the face of the person, so on and so forth, right? So there is a way you describe a person, and definitely different soft characteristics of the person that you will try to describe, right? But if I ask the same question about describing the data, how would you describe the data? If I ask the same question of describing the data, how would you describe the data? Now, to describe the data, what you would do is the first intuitive answer would be, so for example, this is my data. The first intuitive answer is, hey, where is the center of the data? Hey, where is the center of the data? Or you would say, where the data lies on an average. On an average. This is the first question would you would try to answer or try to describe the data by defining the center of the data, by giving the center of the data, if there are a lot of data points. So the first thing that you say is the center of the data. Then the second, you would say, what is the range of the data? When you're saying range of the data, actually what you're trying to describe about the data, you're trying to describe the length and breadth of the data. Basically, you're trying to talk about the spread of the data, the dispersion in the data. So you talk about a dispersion in the data. Or you might talk about whether the data is symmetric or not. Whether the data is symmetric or not. The way you are trying to describe a person face, whether the face is symmetric or not, you will try to describe whether the data is symmetric or not. And the fourth is you might describe the person like whether the person is thin or fat, fat or thin. The same way you will try to describe whether the data is fat or thin. And specifically, not in the body, but in the tails. So there are four ways you describe the data. First is the center, second is the dispersion, the spread in the data, the third is the symmetricity or asymmetricity in the data, and the fourth, whether the tails are thinner or fatter. Or if you don't understand what is tail, whether the data is thinner or fatter. That's it. Okay. So the first question that you try to answer was what? If this is my data, then I was trying to find out the center of the data. This was my first answer. So I would write it as moment one. Moment one. How you find the center of the data? Or in a very statistical or mathematical way of asking the question, what is the average of the data? How you find the average? You would say the answer is mean. But it's not only mean, it is also median and mode. So you can define the center of the data by three measures or three tools, that is mean, median, and mode. And I would recommend to remember mean, median, mode in this sequence, mean, median, and mode. You will understand why after a few sessions. So this is moment one. What it is? This is moment one. So moment one is all about finding the center of the data. Okay, you found the center of the data. Okay, great. You have the center of the data here. Perfect. But the next question that you would ask is, what is the dispersion in the data? What is the dispersion in the data? What is the spread of the data? If I just use the word the spread or the dispersion in the data, then I would say, okay, let's find the range of the data. Perfect. Range is simply highest minus lowest. But if I change the definition, if I change the definition of dispersion and say, find the dispersion of the data from the center. So there are multiple data points. There are multiple data points. These are data points. And you have to find the distance of these data point from the center. Then range will not help you because in range formula, highest minus lowest, there is no center. So you have to fall to other tools or other formulas or other measure to find the dispersion in the data. To find the dispersion in the data, these are mean absolute deviation, these are variance and standard deviation. You might have heard these terms, but these all are required to find out the dispersion in the data. This is the second description of the data. The first was the center of the data. The second description is the dispersion of the data. Why I'm saying description? Because in the moments you're trying to describe the data. In the descriptive statistics, you're trying to describe the data. The second way of describing the data is dispersion. And therefore, we call it as moment 2. Moment 2. So moment 2 is all about finding the dispersion in the data. Finding the dispersion in the data. And there are multiple measures to find multiple tools like range, mean absolute deviation, variance, and standard deviation. Now, the third thing is about symmetricity in the data. Symmetricity in the data. So look into the two different data type. Now, this is one data. This is say the data. And you found the center of the data. This is the center of the data. Okay. This data was somewhat symmetric. This data was somewhat symmetric. However, when you look into this data, the data is moving in the right direction, moving in the right direction away from the center. This is the center of the data. This is the center of the data, and the data is moving in the right direction. Is it symmetric? This is one half. This is another half from the center. Is it symmetric? No, it's not symmetric. It is asymmetric data. And if you say in English, it is a right skewed data. It is skewed to the right, skewed to the right. So I will say it is a right skewed data. However, if this is my data and this is my center, sorry, if this is my center, then you see my data is moving away from the center. Definitely you call it outlier or whatever you want to say, but the data is moving away from the center and it is moving in the left direction, right? So you will call it as a skewed data, but it is a left skewed data. There could be another data where the data is symmetric. So you will say a zero skewed data. But what we are talking here, we are talking about the symmetricity or asymmetricity in the data. What? Symmetricity or asymmetricity in the data, and that is described with the help of moment 3. So this is about, moment 3 is about symmetricity in the data. What? Symmetricity in the data. Whether the data is symmetric or not. Moment 4. For moment 4, we have to discuss normal distribution actually. But for the time being, because we just started our session, let's assume this is a normal data. The way we call a normal human being with a certain height, certain face, symmetric what? The same way in statistics, normal data is represented this way. So this is a normal data. I know most of you know this is normal distribution, but I don't want to speak jargons here. This is a very normal data. A normal human being, a normal data. This section This section is the body of the data. And this section and this section are the tails. You can see these are the tails of the data. So let's focus on the tails only, because now we're only going to discuss about tails. Now, because of evolution, human being doesn't have tails, but we are talking about the fatter or thinner tails in the data. So if I'm saying this is a normal tail, it's good, perfect. But let's see another data. This new data, which is represented by white, has fatter tail or thinner tail than the previous normal data. It has a fatter tails. Let's see another data. Does it have a fatter or a thinner tail? It has a thinner tail. It has a normal tail. Normal tail. Weird to say, but normal tail. So fatter, thinner, or normal tail. So in moment 4, you're trying to understand the tails of the data. And when I say tails, you will learn in moment 4 video that this tail is captured or measured through a term kurtosis. The fatter tails are called as leptokurtic, the thinner tails are called as platykurtic, and normal tails are called as mesokurtic. Okay, so the kurtosis in the data represent moment 4 and it represent the fatter or thinner tail. Okay, and the measure to calculate is kurtosis. And for moment 3, which was symmetricity, the measure to calculate is none other than, as the word suggests, the skewness in the data. Skewness in the data. So what are the measure for moment 1? Mean, median, mode, center of the data. For moment 2, the measures are range, mean absolute deviation, variance, and standard deviation. For moment 3, it's only skewness. For moment 4, it is kurtosis. What it represent? Let's summarize. So there are 4 moments in the data. There are 4 moments. Moment 1, 2, 3, 4. Moment 1 is about center of the data. Moment 2 is about dispersion in the data and also the dispersion in the data from the center. If it is only dispersion in the data, the measure is range. If it is dispersion in the data from the center, the measures are MAD, variance, and standard deviation. In the center, which is the moment 1, the measures as we discussed are mean, median, and mode. Important point for moment 1 and moment 2. In moment 3 and 4, there is only one tool to calculate moment 3, that is skewness, and kurtosis for moment 4. But for center, we have 3. For dispersion, we have 4 and even more. Which is the best? In the next series of videos, we'll talk about moment 1 and try to find out which is the best. So don't worry which is the best for the time being. First, just develop the intuition that what is moment 1, what is moment 2, what is moment 3, what is moment 4. That's it. Okay. Moment 3 is about symmetricity. Measure is only one, skewness. Fatter or thinner tail of the data, kurtosis. Now, one weird thing that you might see in the notation. The notation for each one of them is expected value of the data, which is represented by x. But can you see the power? Here the power is 1, here it is 2, here it is 3, here it is 4. Because it is moment 1, moment 2, moment 3, moment 4. There is a very strong relationship between this power and moment 1, 2, 3, and 4, the numbers. So the formula that you will see, there you will see that the power that we are playing in moment 1 is 1. For moment 2, it's 2. For moment 3 is 3. Moment 4 is 4, which we'll discuss in the upcoming session. So this was the high level, eagle eye view of what moments mean. In the next session, we'll enter into moment 1. That is what? The central tendency of the data, the center of the data. We'll discuss there are 3 measures, okay, mean, median, and mode, but which is the best? The best is defined by the blue. Okay? With that, we'll end the session here. Thank you. Have a nice day.